Okay, let's dive into this. Welcome to This Explainer. Today, we're unpacking something you probably have sitting in your garage or toolbox right now, the drill. We're looking at its history, its mechanics, the whole shebang. But before you picture that heavy, battery-powered chunk of plastic and metal on your workbench, I want you to consider a number that completely blew my mind.
35,000. Yep, you heard that right. That is actually how far back the drill goes. I mean, long before electricity, way before we were forging metal, early humans had already figured out how to bore small holes around 35,000 BCE. It's honestly staggering when you realize our ancestors were out there engineering ways to conquer solid materials over 37,000 years ago.
So early humans used these primitive drills, which historians actually think were likely just modified spears, to pierce through really tough materials. We're talking thick wood, heavy animal skins, things like that. Because think about it, they face this massive fundamental problem. How do you create a clean hole without just, tearing the whole material to shreds? Well, their brilliant solution was rotational friction. And that right there marks the absolute earliest iteration of this incredible technology.
Now, let's fast forward a bit. Ancient woodworkers in Egypt decided to take things to the next level. They essentially looked at the classic fire drill, which obviously was used to start fires, and they ingeniously adapted it into the Egyptian bow drill. By wrapping a cord really tightly around the drill shaft and holding it taut with a curved bow, wow, they created a specialized mechanical tool. It wasn't just a stick held between two hands anymore. It was a bona fide machine powered by leverage. And introducing leverage, that was a massive, massive conceptual leap.
There's this fantastic historical account that perfectly captures how this mechanical operation actually worked. It goes, holding the drill vertically, the operator moved the bow backward and forward, pressing downward on alternate turns with an idle return stroke. Okay, just imagine doing that by hand. You push the bow forward and the drill cuts into the wood. Great. But then you pull it back and the drill just spins backward, doing absolutely nothing. That idle return stroke? Yeah, a pretty major mechanical inefficiency. But still, it was an undeniable, game-changing leap forward in human engineering.
So we know they were working wood and building with it. Makes sense, right? But here is a question for you. What else do you think the bow drill was used for in ancient times? I want you to really brace yourselves for this one, because it is a highly surprising and frankly a slightly wince-inducing piece of history.
9,000 BCE. That is the era where we have the absolute earliest evidence of dental drilling. Yup, no Novocaine, no reclining leather chair. Thousands of years before modern medicine was even a thought, ancient dentists were using the exact same bow drill mechanics we just talked about to literally drill into human teeth. I mean, it is just wild to think about sitting through a dental procedure powered entirely by a specialized wooden bow. Talk about a tough day at the dentist.
And this brilliantly illustrates our chronological quest for rotational energy across human history. You can see the momentum just keeps building. We start way back in 35,000 BCE with the modified spear and push through to 9,000 BCE for that terrifying early dental work. Then the ancient Egyptians come along and refine the process with the bow drill. After that, the Romans take that very foundation and engineer the auger. And finally, during the Middle Ages, the carpenter's brace emerges. Every single era here represents a relentless, totally unstoppable drive to spin a tool with greater speed and force.
Let's actually zoom in on that transition from the Romans to the Middle Ages for a second. The Romans, well, they engineered a highly capable tool with the auger, but it faced a really serious mechanical hurdle. The bit froze between turns. Think about it. You'd twist it, stop, reposition your hands, and twist again. All that hard-earned momentum was totally lost. It wasn't until the Middle Ages that the carpenter's brace finally solved this problem. The crank-like design of the brace made continuous rotation possible for the very first time. No more stopping and starting, just continuous, powerful, glorious cutting.
So the crucial point is that a drill technically comprises two completely distinct elements. The drill itself is simply the machine supplying the rotational energy. It's the muscle behind the operation. The drill bit, on the other hand, is the active cutting tool. It's the specialized component that rotates, makes contact, and actually bites into the material. The whole history we just covered, that was mostly an evolution of the energy supply. Now let's shift gears and look at the incredible evolution of the bit and the modern machine itself.
As you've probably noticed, modern drills have evolved significantly to meet extremely specific material demands. I mean, a basic everyday drill easily handles small holes in softer materials, like wood or basic brick. However, if a project requires boring massive, pipe-sized channels through super dense masonry or solid metal, you are going to need drastically more power.
The form and the function of the modern drill are entirely dictated by the structural toughness of the target material and, of course, the sheer scale of the job.
And you know what the real unsung hero is here? The thing that allows these powerful machines to adapt to all those different jobs? It's the modern chuck. The chuck is that adjustable mechanism right at the very front designed to securely grip the drill bits. Because it can be unscrewed and widened out, it seamlessly accepts completely different, much larger attachments. It literally takes what used to be a single-purpose hole maker and transforms it into an incredibly versatile multi-tool. It's a total game changer.
Just think about the surprising variety of things that a modern, unscrewed chuck can hold. You can lock in sanding tools to smooth down rough timber. You can attach heavy wire brushes to just strip away stubborn layers of old paint or rust. You can mount grinding stones to carefully shape metal. Or, get this, even hook up miniature circular saws. That core rotational energy is harnessed for an endless array of everyday jobs, and it's all because of the chuck's adaptable grip.
Okay, let's slow things down for a second. Let's act as microscopic tour guides here. When we look really closely at the fluted part, or the main body of a modern drill bit, what is it actually made of? Well, today, it's almost always forged from hardened, high-carbon steel. This material is incredibly tough, and frankly, it has to be. To tear through dense masonry and solid metal without just shattering into pieces under all that intense friction and heat, the steel itself must be fundamentally harder than the material it's cutting.
Now, what's really interesting about this slide is the precise step-by-step physical mechanics of how this high-carbon steel actually works to dig a hole. First, look at the tip. It's conical in shape and packed with sharp cutting edges to immediately pierce the surface. Second, notice the angle of the tapering sides at the point. That specific angle isn't random at all. It determines exactly how large of a chip is taken off with each and every single rotation. And third, those twisting helical flutes running up the body, they dictate the drill's cutting properties and actively channel all the removed chips and dust right out of the hole so the drill doesn't jam up. It is, without a doubt, a true masterpiece of cutting geometry.
Which brings us to a final thought. The next time you open your toolbox and pick up your drill for a quick weekend DIY project, what are you going to see? Will it just be a simple piece of hardware to you, or will it be 37,000 years of continuous human engineering? From a modified spear to the high-carbon steel resting in your hands right now, we have always been driven to shape the world around us. Thank you so much for joining me for this explainer. Keep learning, keep building, and I will see you next time.